The youngest exoplanet yet discovered is less than 1 million year old and orbits Coku Tau 4, a star 420 light-years away. Astronomers inferred the planet's presence from an enormous hole in the dusty disk that girdles the star. The hole is 10 times the size of Earth's orbit around the Sun and probably caused by the planet clearing a space in the dust as it orbits the star. Credit NASA. Exoplanets are planets beyond our own solar system. Thousands have been discovered in the past 2 decades, mostly with NASA's Kepler space telescope. These worlds come in a huge variety of sizes and orbits. Some are gigantic planets hugging close to their parent stars, others are icy, some rocky. NASA and other agencies are looking for a special kind of planet, one that's the same size as Earth, orbiting a sun-like star in the habitable zone. The habitable zone is the range of distances from a star where a planet's temperature allows liquid water oceans, critical for life on Earth. The earliest definition of the zone was based on simple thermal equilibrium, but current calculations of the habitable zone include many other factors, including the greenhouse effect of a planet's atmosphere. This makes the boundaries of a habitable zone fuzzy. Astronomers announced in August 2016 that they may have found such a planet orbiting Proxima Centauri. The newfound world, known as Proxima b, is about 1.3 times more massive than Earth, which suggests that the exoplanet is a rocky world, researchers said. The planet is also in the star's habitable zone, just 4.7 million miles (7.5 million kilometers) from its host star. It completes one orbit every 11.2 Earth days. As a result, it's likely that the exoplanet is tidally locked, meaning it always shows the same face to its host star, just as the Moon shows only one face, the near side, to Earth. While exoplanets were not confirmed until the 1990s, for years beforehand astronomers were convinced they were out there. That wasn't just wishful thinking, but because of how slowly our own sun and other stars like it spin, University of British Columbia astrophysicist Jamie Matthews told Space.com. Matthews, the mission scientist of Occasional Exoplanet Telescope Observer, most microvariability and oscillations of stars, was involved in some of the early exoplanet discoveries. Astronomers had an origin story for our solar system. Simply put, a spinning cloud of gas and dust called the Proto solar nebula collapsed under its own gravity and formed the Sun and planets. As the cloud collapsed, conservation of angular momentum meant the soon-to-be-Sun should have spun faster and faster. But while the Sun contains 99.8% of the solar system's mass, the planets have 96% of the angular momentum. Astronomers asked themselves why the Sun rotates so slowly. The young Sun would have had a very strong magnetic field, whose lines of force reached out into the disk of swirling gas from which the planets would form. These field lines connected with the charged particles in the gas, and acted like anchors, slowing down the spin of the forming Sun and spinning up the gas that would eventually turn into the planets. Most stars like the Sun rotate slowly, so astronomers inferred that the same magnetic braking occurred for them, meaning that planet formation must have occurred for them. The implication: planets must be common around Sun-like stars. For this reason and others, astronomers at first restricted their search for exoplanets to stars similar to the Sun, but the first 2 discoveries were around a pulsar rapidly spinning corpse of a star that died as a supernova called PSR 125712 in 1992. The first confirmed discovery of a world orbiting a Sun-like star, in 1995, was 51 Pegasi B, a Jupiter-mass planet 20 times closer to its Sun than we are to ours. That was a surprise. But another oddity popped up 7 years earlier that hinted at the wealth of exoplanets to come. A Canadian team discovered a Jupiter-sized planet around Gamma Cephei in 1988, but because its orbit was much smaller than Jupiter's, the scientists did not claim a definitive planet detection. We weren't expecting planets like that. It was different enough from a planet in our own solar system that they were cautious, Matthews said. Alien Worlds infographic 20x60 poster. Buy your credit. Space.com store. Most of the first exoplanet discoveries were huge Jupiter-size or larger gas giants orbiting close to their parent stars. That's because astronomers were relying on the radial velocity technique, which measures how much a star wobbles when a planet or planets orbit it. These large planets close in produce a correspondingly big effect on their parent star, causing an easier-to-detect wobble. Before the era of exoplanet discoveries, instruments could only measure stellar motions down to a kilometer per second, too imprecise to detect a wobble due to a planet. Now, some instruments can measure velocities as low as a centimeter per second, according to Matthews. Partly due to better instrumentation, but also because astronomers are now more experienced in teasing subtle signals out of the data. Today, there are more than 1,000 confirmed exoplanets discovered by a single telescope, the Kepler Space Telescope, which reached orbit in 2009 and hunted for habitable planets for 4 years. Kepler uses a technique called the transit method, measuring how much a star's light dims when a planet passes in front of it. Kepler has revealed a cornucopia of different types of planets. Besides gas giants and terrestrial planets, it has helped define a whole new class known as super-Earths, planets that are between the size of Earth and Neptune. Some of these are in the habitable zones of their stars, but astrobiologists are going back to the drawing board to consider how life might develop on such worlds. In 2014, Kepler astronomers including Matthew's former student Jason Rowe unveiled a verification by multiplicity method that should increase the rate at which astronomers promote candidate planets to confirmed planets. The technique is based on orbital stability. Many transits of a star occurring with short periods can only be due to planets in small orbits, since multiply eclipsing stars that might mimic would gravitationally eject each other from the system in just a few million years. While the Kepler and French Kourou planet hunting satellites have ended their original missions, scientists are still mining the data for discoveries, and there are more to come. MOST is still operating, and the NASA Test Transiting Exoplanet Survey satellite, Swiss CHIPS characterizing exoplanets satellite and ESA's Plato missions will soon pick up the transit search from space, from the ground. The HARP spectrograph on the European Southern Observatory's Lucilla 3.6-meter telescope in Chile is leading the Doppler wobble search, but there are many other telescopes in the hunt. One too-neglected example, Matthews said, is NASA's Spitzer Space Telescope. Because it is sensitive in the infrared, it can sense the temperature profile of an exoplanet and give insights into its atmosphere. A diagram showing the relative sizes of the new alien planets discovered by Kepler, compared to Earth and Jupiter. Credit NASA Timpile with almost 2,000 to choose from. It's hard to narrow down a few. Small solid planets in the habitable zone are automatically standouts, but Matthews singled out 5 other exoplanets that have expanded our perspective on how planets form and evolve. 51 Pegasi B. As mentioned earlier, this was the first planet to be confirmed around a Sun-like star. Half the mass of Jupiter, it orbits around its Sun at roughly the distance of Mercury from our Sun. 51 Pegasi B is so close to its parent star that it is likely tidally locked, meaning one side always faces the star. HD 209,458b. This was the first planet found in 1999 to transit its star, although it was discovered by the Doppler wobble technique, and in subsequent years more discoveries piled up. It was the first planet outside the solar system for which we could determine aspects of its atmosphere, including temperature profile and the lack of clouds. Matthews participated in some of the observations using MOST. 55 Cancri. This super-Earth orbits a star that is bright enough to see by eye, meaning astronomers can study the system in more detail than almost any other. Its year is only 17 hours and 41 minutes long, recognized when MOST gazed at the system for 2 weeks in 2011. Theorists speculate that the planet may be carbon-rich, with a diamond core. HD 80,606b. At the time of its discovery in 2001, it held the record as the most eccentric exoplanet ever discovered. It is possible that its odd orbit, which is similar to Halley's Comet around the Sun, may be due to the influence of another star. Its extreme orbit would make the planet's environment extremely variable. Wasp 33b. This planet was discovered in 2011 and has a sort of sunscreen layer, a stratosphere, that absorbs some of the visible and ultraviolet light from its parent star. Not only does this planet orbit its star backward, but it also triggers vibrations in the star, seen by the MOST satellite.